Hey, so today we're going to be talking about saving money. Now, this is one of the more daunting chapters, in my opinion. Some people really get it, and some people struggle with it, and I'm one of the people who struggles with it. It's just money is something that's kind of hard for me to wrap my head around when it comes to big investment stuff. But we'll get through it together. Now, here is just a bunch of formulas, just like 12 gazillion big numbers and stuff like that. We don't need to memorize these at all. You will be given these on your test. Do not be daunted by them. You don't have to memorize them at all. It is not something you have to do. All we need to know is how to utilize them. And I also have more good news. If you have Excel spreadsheets, you don't even need to plug them into your calculator. You just need to know what to plug into Excel. Excel is going to be our best friend for this unit, I think. There's so many things that you can mess up, I feel, if you just plug this into your calculator. If you're tricky, like if you're a calculator genius, a calculator whiz, and you're a pro at plugging stuff into your calculator, then go for it. You can do that. If it makes sense to you, then do that. If it makes it nice, do that. Do whatever makes you happy. Personally, I am lazy. I like doing the least amount of work. So I am going to be using Excel for this. Before we hop into examples, I'll explain what each of these do. So the present value formula. So present value is equal to the amount divided by 1 plus rate over how many times it compounds, and then to the n times t. Now, it's kind of daunting, but let's break it apart. When it's talking about present value, it's basically saying what is the lump sum that you need to invest initially. Yeah, you heard me say that word, lump sum. That's a really key word. Sum. If you see this in your problems, what is the lump sum? There's a good chance that you're going to be looking for present value. So you'll be putting in your amount that you need to get. I'm pretty sure. Yeah, the amount that you need. And then your rate and the amount of times it compounds. And then we have our annuity formula for finding future value. Now that's kind of a gross title, so let's break it down. So the future value is equal to payments times, our payment amount, times, it's going to be gross to write out, brackets, parentheses, 1 plus rate over amount of times it compounds, to the amount of times it compounds times the time, and then minus 1, and that is a bracket, and it's our top part, over our rate divided by our amount of times we compound. So, yeah, when we're talking about future value, typically what it's talking about is, so you have a payment, you are trying to save for retirement or something, and you want to know how much money you'd have in your retirement account if you put in, say, $300 per month. So you'd put $300 times 1 plus let's say you have a rate of 7% again, which is, I don't even know, I feel like that's crazy, but divided by 12 to the 12 times, let's say 35 years. That feels typical. I'm kind of impeding on their space. Minus 1 divided by our rate, which was 0.7%, divided by our amount of times that we compound. Yeah, kind of a mouthful. That would let you know how much money you have if you deposit $300 into account monthly for 35 years. And that's a typical formula that we use for trying to figure out how much you need to save for retirement. our annuity formula for finding payment amounts. So this is where you have the future amount that you want to save up for, let's say like $1 million. I feel like that's an okay goal. You want $1 million when you retire. And then it would be times our rate over n divided by 1 plus r over n to the nt minus 1. Kind of a mouthful. So this would be determining how much money you would need to deposit, whether it be monthly or quarterly or whatever, in the amount of time, say 35 years or whatever, to have $1 million. Hopefully that makes sense. One thing to notice is, if you remember our exponent rules, if we have like 1 over x to the nt, that can be written the same as x to the negative nt, right? So with the PV, the present value formula, and our payment function, when we type that into Excel, when we're typing the, I think it's number of periods, 1 minute, PMT, when we're typing in our NPER, number of periods, and I'll go over the Excel functions in just a moment, you're going to want to make those negative. Yeah, because they're below. It's 1 over NT, right? Just keep that in mind when you're plugging that into Excel. Or your calculators wouldn't matter necessarily because you're putting it divided anyway. But I don't really recommend doing it in your calculator unless that's something you really want to do and feel comfortable with. I just would not. I don't want to do that. So let's jump into some example problems. Okay. Hale College predicts that in 18 years, it will take $200,000 to attend college for 4 years. Madison has a substantial amount of cash and wishes to invest a lump sum of money for her child's college fund. How much should Madison put aside in an account with APR of 11%, compounded monthly, in order to have $20,000 in the account in 18 years? So, here's a hint. The 4 years is irrelevant. We don't care about that. It doesn't have anything to do with our savings. That's just saying how much money it costs to attend the college for like a bachelor's or whatever, like a 4-year degree program. So we have our hints here. We want a lump sum. We are not putting in payments, so any formula that deals with payments, we don't care. So we don't care about this one and we don't care about this one because they both deal with payments. We are looking for the present value formula. We know that we want $200,000 and we want to find the lump sum. We know the APR is 11% compounded monthly. So let's take a field trip into Excel. We want the present value formula. So equals present value is our formula for present value. Well, equals PV. So our rate, if you remember, was 0.11. But we also have to do the divided by n part. The divided by the amount of times it compounds. Divided by 12. Comma. The number of periods. And if you remember, we have 18 years and monthly. And we are using the present value formula. So we are going to need the negative NT this time. So negative 18 times 12. And then the payment is going to be 0 because we don't have a payment here. We know 0. We know the future value is going to be $20,000 because that's how much we want. And I usually leave the last part blank. You don't need to worry about the type. And, whoops, I must have done something wrong. 1 sec. Give me just a moment. Okay, yeah. So you, I actually do not believe that you use the negative for this one. I don't know why I believed that, but, well, I do know why. It's because of that negative part. But when we're typing it into Excel, we're thinking about number of periods, and there's going to be 216 periods, not negative 216 periods.
I got that mixed up in my brain. I do feel like there is a negative at some point, but that might be a 9.4 actually. I'll have to double check. We may come across a problem that deals with a negative, but for this one specifically, it's going to be positive 18 times 12. Sorry about misleading you there. So when we run that back, I'm going to do the normal formula for finding the compounded interest formula with this lump sum times our 1 plus our rate divided by 12, and then to the 2/16th power, which is 12 times 18. And that gives me $200,000 and a few leftovers. But basically that is the correct answer. So we need, I already lost it. 27864. 2786405. 2786405.05. So this much money in our lump sum. Sorry about mixing it up with the negative exponents part. Hopefully that makes sense. I do know that there will be a time when we will be using that negative. We'll cross that bridge when we get to it. Like I said, the financial stuff kind of messes with my head. But we'll do it. We'll be good. It'll be all right. It's good stuff to know. Chase starts an IRA, individual retirement account, at the age of 24 to save for retirement. He deposits $350 each month. Upon retirement at the age of 65, his retirement savings is $1,090,131.43. We want to determine the amount of money Chase deposited over the length of the investment and how much he made in interest upon retirement. Sorry. So, this one is kind of trying to trick you a little bit. It gives you the formulas here, and it'll give you these same formulas. But you look over this, you're like, hold on. I'm not seeing a rate, which is in every single equation. So I don't know how to do this. It's like, I don't know which formula to use. However, when you have something like that, it probably requires a little bit more looking at the problem and thinking about what you need to do. Thinking about it in an English perspective rather than in a math perspective. We know that we are trying to find the total amount deposited. He deposits $350 each month, right? So we can take $350 times 12, because he does it each month, and then times the amount of years, which is 65 minus 24. Which should give you... So he deposits $172,200 into the account. Now we know how much he deposited, but we want to know, we also want to know how much he earns in interest. Now you still have I don't know what to do here. I still don't have the rate kind of problem, but we just want to keep using our English brains. If we know that his retirement savings has $1,090,131.43, and we know that he deposits $100,000 roughly, we can probably just minus that, right? Because if he's not depositing it, it's probably being earned in interest. So we take our $172,200 and subtract that, and we should get $917,931.45. I don't know where that extra 5 is. I put 5 instead of 3. So I get this. So I put that in there. So 917,931.43. That one throws people off, but it's probably the easier one. It's just our brains are primed to think in these crazy wonky formulas that are really intimidating. So we think that this will fit into that. But sometimes some curveballs are thrown just to get you thinking about the problems, if that makes sense. So, suppose that you'd like to save money to pay cash for your next car. The goal is to save an extra $25,000 over the next 6 years. What amount must be deposited quarterly into an account that earns 4.9 interest, compounded quarterly, in order to reach your goal? Round your answer to the nearest cent if necessary. Okay, save an extra $25,000 over the next 6 years, quarterly, into an account that earns 4.9 interest. It's also compounded quarterly. So we want to save $25,000. We want to know what amount must be deposited quarterly. So that gives you a hint that we'll probably be using the payment formula and 4.9 interest. So what we can do is we can go into Excel. I'll delete these for now. And we are wanting to find payment. So we'll do the PMT formula. Payment. The rate is 4.9, so 0.049. And then divided by 4 because it's compounded quarterly. And then 4 times, and I lost how many years we're doing. Next 6 years. Okay, so 4 times 6. And then present value, which is 0 because we have not deposited any money yet. And we want, was it 25,000? Yeah, 25,000. Oh, whoops, I forgot a comma. And then we can leave type blank. And we get $902.36. So 902 and 36.36. That would be your payment, your quarterly payment. Let me double check. Why does it let you do that? Yep. Oh, whoops. Yep, that should be right. Okay, yeah. So, well, we can check. We can do the future value formula. So equals future value, which is FV. Rate is 0.049 divided by 4. Comma, number of periods is 4 times 6. And the payment is E4, which is 902.36. And the present value is still going to be 0. And we still put nothing for type. And that gives us $25,000. So that was a correct answer. Yep. Okay, last problem. Home stretch. Julieta and Eric are purchasing a home. They wish to save money for 15 years and purchase a house that has a value of $160,000. Sorry, with cash. If they deposit money into an account paying 7% interest, compounded monthly, how much do they need to deposit each month in order to make the purchase? So we want to know how much to deposit each month. That's a good hint for the payment function. We're given our value of the home, which is really low for right now. It's sometimes Hawks is like that. It's going to be 15 years and 7% interest. So we'll go in with our information. No, we'll keep that formula. So equals payment. We'll need to change some items up though. Our rate, I already forgot. 7%. 0.07. And I believe it was monthly. Yep. And then our number of periods is 12 times, I believe it was 15 years. Let's double check that. Yep. And then our present value is still 0. And our future value, I believe it was 15. Wow! 16. Okay, 160. 1 2 3. Which gives us this. We need to change up the 4.9 to 7 instead. And we need to change the 4 to 12 and our 6 to 15. Uh-oh, hold on. I might not have changed everything. Give me 2 seconds. Okay, I know what I did. I accidentally, I didn't replace the 4 with the 12. So, yeah. Whew. So that checks out. We get the $160,000. I don't know why I'm having such problems saying numbers tonight. Sometimes it's like that. So that is our answer. The 504. 504.79. That would be our answer for that. Hopefully that makes sense. If you have any questions, please let me know. Again, I know that sometimes the problems on Hawks, I don't cover all the ones that you might see. If you are having problems with a specific one, please let me know, and I will address that as soon as possible. Yeah. Sorry for such a long video. These tend to get long. But yeah, have a good day.